Well, my homeroom's not here, so I thought I'd try something that would remind me of them. Oh, no. Seriously, this is an introduction to Newton's third law for this episode. Now, if one object exerts a force on another object, then the second object exerts a force of equal strength in the opposite direction on the first object. Or, for every action, there's an equal and opposite reaction. So, when these little guys are pushing down on the table's pushing back up on them. That's why they hop around. Okay? All right. So, yeah. Get the last word in. So, we have what are called action and reaction pairs. Equal forces, opposite direction, two objects. And again, there's one interpretation and many applications. For instance, you play volleyball or something, you hit it with a ball. There's a force on your wrist, but there's also a force on the ball, and they're equal. Okay? Or like when you jump, just like these little guys jump. Not very well right now, but they did. You push down on the ground pushes up on you. Okay? So, let's go outside and take a look at this a little bit. A couple action-reaction pairs. We'll come back and discuss it a little bit more. Thanks for help, Bob. You can pick them up. A lot of toys are based on Newton's laws. This one happens to be based on Newton's third law. It's a rocket. Okay? So, what you do is you pour a little water inside there. You can see the water inside there sloshing around. They come with a little funnel, but all little funnels are at school. Because I remember the rocket and I remember the pump, but I forgot that part. So I got 66% of this. Okay, I wanted to put some math in there for you. So we're going to close that up, seal that up, and then you pump this up. 200, 300, whatever. Okay, now pull this back, and what's going to happen is the pressurized air in there is going to push on the water. Well, the water's pushing on the air, which is pushing on the rocket, which is pushing back on the air below it. And so together, Newton's third law. Action-reaction pairs. Okay? So here we go. Oh, sorry, Mrs. Robin. You know, Bob, what? Oh, yeah. We're Americans. We can do this bigger. What if we get a bigger air pump and a bigger Bob? But, yeah, that'll be fun. But we need to get out underneath these trees. We might have rockets, but Mrs. Robin can bomb us. That's why you wear a hat, Bob. All right. Okay, Bob. Let's test out Newton's third law. The air is pushing down on the water. The air is pushing up on the rocket. Let's see. 3, 2, 1, blast off! Woohoo! Woohoo! How about that one, Bob? Okay, here we are. We've got our bottle rocket. We've pumped some air into it. Alright. And Bob there is checking the wind to make sure we're okay. We're out here in the open so everybody's safe. And we'll see what happens here. Alright. 3, 2, 1. Lift off. Oh, you look a little damp there, Bob. You're all right. Okay, Bob. Let's test out Newton's third law. The air is pushing down on the water. The air is pushing up on the rocket. Let's see. 3, 2, 1, blast off. Woohoo! Woohoo! How about that one, Bob? All right, we'll put a pump or two in here, Bob. All right, here we go. watch this, Bob. Great reflexes there, Bob. I think they're called pathetic. Not as good as my drawing skills. We're on an equal balance here. That balloon took off because of action-reaction pairs. Just like the rockets we saw outside. Equal forces, opposite direction, two objects. In this case, with the balloon, as with the rockets outside, you have the air inside, pushing in all directions, but when you open it up, the air inside is pushing out, and the air outside is pushing back on it, so there's your action-reaction pairs, and off it goes. So, that brings us to the end of this episode of Garage Science. See you next time.